Hola, chaps. Let's learn. Hola, chaps. Mr. Turek here. This is for physics. For the tape lab, if you don't have the exact list of materials that I have on the handout, but you still have magic tape, please just go ahead and substitute your own materials. But if you're one of those poor, unfortunate students who don't even have some sort of transparent tape at home, I'm going to try to collect some data for you right now. So first, I'm going to get rid of the lead piece here in case it's just been sitting there forever. And now I'm pulling a fresh reference strip off the tape and I'm setting it against this wood block with the overhead camera looking down on it from above. So here's my hand below it. And what you need to pay attention to is the behavior of this strip. You're looking down on it from above in this view. And I'm going to work through some of, well, try to test it against some of these materials listed on the sheet. The first one says lab table. The closest I have to that is the table I'm sitting at. So I'm going to set this on the table that I'm sitting at and then rip it off and turn it around. And I'm going to bring the sticky side towards the sticky side. Very strong attraction taking place here. So I'm bringing the, let me rearrange this. I'm bringing the test strip, I'm bringing the test strip in from above, and when it approaches near the reference strip, they strongly attract to each other. So there's one data point, attract. You get to fill in all the rest of it. On aluminum foil, I tried to cut off a little piece of aluminum foil, ended up cutting off a big piece of aluminum foil. Doesn't matter. So I'll use a little piece anyways. Test strip onto aluminum foil. And now I rip it off. Of course, helps if you fold the tape before you do this sort of thing to make it easier to rip off. Here's ripped off. I bring it near the reference strip and you can see, well, you can't see very well, but I can see quite well that they strongly attract each other. In fact, I don't even want to tell you what I observe. I just want to put this up there and you write down the observation that you make yourself based on what you see. All right, next one. This is a block of wood from a wine rack that was built sometime in the 1800s. And I cut off this little piece of it. Stuck the tape onto the end of the wood block. I'm not going to tell you what that one did. Next, for the glass mirror, I decided you don't want to see me in the glass mirror. So I pulled out a glass lens because a glass mirror is silvered on the back of the glass. So it doesn't really matter what the glass object is. It could be a glass drinking container. It could be a window. Here I have a glass lens. Ooh, yeah, ooh. A glass lens. I suppose the fun part would be when I go like this, right? Okay. All right, so with this glass lens, fresh piece of tape, a really long one, accidentally, sticking it down on the lens, ripping it off, turning it around, bringing it near. Huh. Okay, so that was glass lens instead of glass mirror. Cotton fabric. This shirt's close enough. Oh, I'm stuck on learning physics. Hmm. On the plastic side of the tape. I suppose that would be just the tape itself without sticking it on anything else since it just came off the plastic side of the tape on the spool. Next one, wax paper. Turns out we don't actually have wax paper in my home. I used to use it, but my wife always uses parchment paper, which is different. Wax paper you would not put into an oven. Parchment paper you can and do. So I'm substituting parchment paper for what would have been number 8 on the sheet. Doesn't stick much. I'm trying to find a decent way to maneuver this so you can see what's going on. I think my hand's in the way too much on that one. Let's try it like this. Again, what you're looking for is a very subtle change here on this reference strip. How does it react when I bring the test strip near it? Does it try to deflect away from it, meaning they repel? Or does it bend towards it, meaning they attract? And I'm always trying to put the test strip between the wood block and the reference strip that's dangling here. And in this case, this is parchment paper instead of wax paper. All right, saran wrap. Yes, we actually have saran wrap in my home. This is where I need you students to do this stuff for me, right? Okay, I think I got it pretty backwards. Whoa, okay, not a wardrobe malfunction, equipment malfunction. So I'm still trying to do this in a way that you can see it. This one is very subtle. I'm going to declare that it has a very weak attraction for saran wrap. A very weak attraction is my best judgment. For a paper plate, well, paper plates often are coated with wax. You can kind of see this thing glinting here. So I'm going to use the back unwaxed side of this paper plate as my test material. Done with these materials. stick it onto the paper plate, rub it down, rip it off, and now fight for a long time trying to figure out how to show it to you. Okay, the reaction you're looking for, again, if this bends away, that means that they're repelling. If it bends towards the test strip, that means they are attracting. Sandpaper from my garage. This is 100 grit. Sticking it down, rubbing it, well, pressing it. And some sandpaper came off with it, but such is life. Subtle, huh? I'm going to put a fresh reference strip on already because the interactions are a little bit subtle. So, fresh piece of reference strip. Of course, you can't see it unless I move it there. Okay. Next one is skin. Oh, you guys are stuck on me. I assume it doesn't matter where on my skin I do this, but skin. I suppose this is a way of seeing if I really am human, since I should have the same results as you humans. Hmm. So if you do this with your own materials, I'm okay with that. List what the material is, like cross it out. I came up with a few additional materials that I just, saw and said, "Oh, I happen to have a nearly dead balloon." What do you suppose would happen if you stuck a piece of tape to a nearly dead balloon and then ripped the tape off? Find out. I'm sticking the tape to the balloon. Reminds me of a story. Haha, didn't happen. But one year in physics class, we bought a weather balloon and we were going to attach a camera to it, fill it with helium, and launch it way up, you know, thousands and thousands of feet up. Well, while the balloon was getting pressurized, the camera was attached by tape to the balloon, and the student decided, that doesn't look too good. Let's fix it. Well, when he pulled the tape off, the balloon burst. And that was about $100 worth of helium that the class had put together for that project. It was a 15-foot weather balloon. Boom. Subtle, but it's there. All right. So that was for the rubber balloon. For chemistry, I have this block of iron. Might as well use it as a test substance here. So test strip onto an iron cube. And of course, you're trying not to test the part where you're holding it. That is a pretty No result. I would say almost no result. However, subtle. I'll declare that one to be tracked. My last item is a piece of PVC piping. Test strip stuck on the PVC pipe. Great. When I ripped it off, it bent back on itself because it has such strong electrical attraction. What's when I bring it near this? Not much. And it's dirty as well. Swell. So, let's not even bother with that one. I'll just cross that one off the list and say, well, you're on your own. If you can find materials in your home, a sibling, stick it on their skin, clothing, maybe you want to try nylon instead of cotton. You're welcome to adjust the materials that you select to test. The real question is, do you have some sort of magic tape or transparent tape? That's the necessary ingredient. If you don't have that, then base your analysis filling in the data table on the data that I just shared with you. All right, ciao.